Hello students, today we're going to talk about lines in the coordinate plane. In your geometry books, this is chapter 3, section 6. So, what I'd like for you to do is go ahead and pause the screen and try solving these two problems on your own. Now, if you've paused the screen, you should have been able to get the answer x equals 103 degrees. And the reason why we do this is because this is a pentagon. That means that the sum of the interior angles equals 5 minus 2 times 180 degrees, which is equal to 540. So that's how we're able to get this answer. And so we get 540 degrees and we subtract all of the angles from the 115, 105, 117, and 100, and we're left with 103 degrees. For question number 2, the measure of the interior angle and exterior angle for a regular pentagon. Well, we know the angle for interior angle is equal to n minus 2 times 180 degrees divided by n, where n is the number of sides. So because we have a pentagon, then we know it's 5 minus 2 times 180 divided by 5. And that just so happens to be, sorry, let's do these calculations really quick, 108 degrees. For the exterior angle, that's equal to 360 degrees divided by n. And since the number of sides in this instance is 5, then we know that our exterior angle is equal to 72 degrees. So now let's look at your purpose. So at the end of this lesson, you should be able to manipulate linear equations. And the most common types of linear equations are slope-intercept form, point-slope form, standard form, or slope formula. For the slope-intercept form, we have y equals mx plus b, where m is equal to slope, and b is equal to y-intercept. For the point-slope form, we have y minus y sub 1 equals m times the quantity x minus x sub 1. Standard form is ax plus by equals c. And note, a, b, and c are not fractions. So it's a really important thing to notice. Last thing is for the slope formula. The slope formula is defined as y sub 2 minus y sub 1 divided by the quantity x sub 2 minus x sub 1. So this really just finds the change in our x's and our y's. So I've also worked on creating a shortcut to help you guys determine these numbers, or determine the slope in a much more efficient and faster way. So the way that we like to look at this is in terms of x's and y's. So for our x's, or for our y's, we put that on top and we try to calculate how did we get from 3 to 6. We had to add 3. And then what we do is we look at the y, or the x's, and we put the x's always on the bottom. So how did we get from 2 to 5? Well, in that case, we added 3. And because we did our y's on top and x's on the bottom, we actually have the fraction 3 divided by 3, or 3/3, which is equal to 1. So what you're going to be responsible for in the next two equations, let's take one of these out for you, is, first of all, we need to determine the form that each equation is in and then graph it. So, for example 1, what we can actually do is look back the last page and see which one it matches the most. And in this instance, this is actually the slope-intercept form, And for number 2, this is in the standard form. Now the problem is how do we graph this? So in order for us to graph the slope-intercept form, we need to be able to determine what the y, or what the slope is, and what the y-intercept is. So because we know it's y equals mx plus b, we're going to play match a little bit. The b, well, with the y is there, equals is there. The x's, we have 1x. Therefore, our m, or our slope, is 1. And our y-intercept is 2. So the way that this works in terms of graphing is we plot the y-intercept, which in this case is 2. So 1, 2. And the slope, which is, again, slope is rise over run. So rise over run. And because the slope is 1, we have 1 divided by 1. So in blue, it means from our y-intercept, we're going to rise 1. And because it's positive, we go up. And we run 1. And because it's positive, we go to the right. So we have those 2 points that we're able to plot. And we're going to go ahead and draw a line connecting the 2. So that's it for graphing. So let's try example 2. Standard form, we have a couple different ways. One, we could make this look like the slope-intercept form, which is y equals mx plus b, or graph these using intercepts. So if we wanted to go the intercept route, we're going to find the x-intercept, then we're going to find the y-intercept. And the way we do this is we actually take the equation, and we're going to solve it twice. So, to find the x-intercept, what we do is we let the opposite value be equal to 0. So we let y equals 0. So we have 10x equals 40. Therefore, x equals 4. So our x-intercept is 4. So the ordered pair for that is 4, 0, because we let y be equal to 0. For the y-intercept, we let x be equal to 0. Therefore, we have 5y equals 40. Then we're going to divide by 5 to both sides. We're left with y equals 8. And the ordered pair for that would then be 0, 8. So we're going to plot the x-intercept, which is at 4, 0. So 4, 0, 1, 2, 3, 4, and 0. And for the y-intercept, it's going to be 0, 8. So 0 left and right, and 8 up. So 1, 2, 3, 4, 5, 6, 7, 8. We're going to cheat a little bit, and we're going to go 8 up. And connect the dots. So we'll have this graph, and that'll be it. For these, they're giving you the slope and an ordered pair, and they're asking you to write each equation in standard form. So what I tend to do is look at what they give you, and in this case they give you a slope and they give you a point. So because in question 1 we have the slope and we have the point, we're going to use point slope form. Makes sense, right? So point slope form is y minus y sub 1 equal to m times the quantity x minus x sub 1. And because they gave us the y value for the point, that's going to be 3 equal to the slope 2 and x minus 2. They asked us for standard form, so keep in mind standard form looks like ax plus by equals c. So we're going to distribute that too, so y minus 3 equals 2x minus 4. We're going to Then what we're going to do is notice we have the x and the y on the same side. So what we're going to do is we're actually going to move this minus 3 because the constants are supposed to be on the right side. We're left with y equals 2x minus 1. And because we want the x and y on the left side, I'm actually going to subtract 2x from both sides, leaving us negative 2x plus y equals negative 1. Now, notice that this is in line with what we have for our standard form. Therefore, we're done. Problem number 2, we're actually going to skip because I think you guys can do that one. But it's the same criteria. Oh, actually, I take that back. Let's go ahead and solve number 2, because the only difference between 1 and 2 is that you're not given the slope. So again, to figure out the slope, we're going to draw from one y to the other and see how we got there. So from 2 to 4, we added 2. And for the x's, which we always do on the bottom, 6 to 2, we actually have to subtract 4. So our slope is actually equal to negative 2/4 or negative 1/2. At this point, it's the same as example 2. Now it's your turn. Go ahead and try problems 1 and 2. And when you're done, please post your answers to Edmodo.